Okay, so we have this problem, f of x equals 2 secant x plus tangent x on the interval 2 pi to 4 pi. We want to find all of the critical values. So we start by finding the derivative. Derivative of 2 secant x would be 2 secant x tangent x plus the derivative of tangent, which would be secant squared. So we start by figuring out when is the derivative undefined. Both secant and tangent involve a denominator cosine. They're undefined when cosine is 0. Cosine is 0 at pi over 2 and at 3 pi over 2, but we're in the interval 2 pi to 4 pi, so we have to take those values and go around one full revolution, giving us the values 5 pi over 2 and 7 pi over 2 being ones of interest. Then we want to find when the derivative is 0. We're going to make one quick little correction here. That would be 2 secant x tangent x plus secant squared x. So our derivative there is 2 secant x tangent x plus secant squared. We want to find out when that's 0. So I can do a little bit of factoring here. Take out secant x. Now secant x is 1 over cosine. And of course, being a fraction, or if you remember the graph of secant, we know that that's never going to be 0. So we come to the problem of, okay, the only time it's ever going to be 0 is if 2 tangent x plus secant x is 0. Well, tangent well, we find the reference angle first. What angle would give us a sine of 1/2? Well, the then says, oh, it's going to be pi over 6. We then take that angle. We want to know not when it's 1/2, but when it's negative 1/2. And we take that angle and put it into the 2 quadrants that make sine negative. So sine is negative in the 3rd quadrant. So we put in our reference angle, and it's also negative in the 4th quadrant. So we'll put in our pi over 6 reference angle in both of those quadrants. Now that would normally lead us to the angle 7 pi over 6, or the angle 11 pi over 6. But our values are in the interval 2 pi to 4 pi.
Okay.
So putting these into the interval 2 pi to 4 pi, we have to add 2 pi onto both of them. And we have to add 2 values. So the derivative is 0. And 23 pi over 6. The question is, what's our critical values? So that's when it's 0. The other values were when it was undefined, which we can pull back from the last page, which were 5 pi over 2 and 7 pi over 2. Now these last two, as far as critical values, won't be counted, because our original function up here, 2 secant x tangent x is not defined at those, so those don't qualify as critical values. So, in answer to the question as it was originally asked, what are our critical values? 19 pi over 6 and 23 pi over 6. Now once we found these critical values, we can then ask other questions. Once we found all these values where it's 0 or undefined, we can ask other questions like, when is it increasing, when is it decreasing? Now for increasing and decreasing, we want everything. Just asking a technical definition for critical numbers, those are the values we